All right, hey there, it's Mr. Leong. In this video, I want to uh, talk about histograms and kind of motivate a need for why we need histograms. As you can see here, I've got a dot plot of like 507 adults. I know it's 507 because if I look at this part of the software over here, it's telling me how many individuals are in this data set. Um, and the variable that we're looking at is abdominal girth measured in centimeters. Right? So normally we don't make dot plots when we have like large data sets, but because it's software, the software can do it pretty easily for us. So a dot plot can answer kind of simple questions like, what's the shape of this distribution? Okay, it's a bit skewed to the right. What's the abdominal girth of the largest person? Just kind of look over here. And we can see that it is 121.1 centimeters. We can talk about the range, right? Because we know that's the maximum and the minimum's down here. We can estimate the center, probably about 82, maybe 83, seems to be where a lot of those dots are piling up together. But what about a question like this? How many people had an abdominal girth of over 100? Is that something that you can quickly answer with a dot plot? And the answer is no, right? Because you would need to count all these dots here, and that would take you quite a bit of time. So dot plots aren't the best graph to use when it comes to answering questions of how many individuals fall within a certain interval or what percentage of individuals fall in a certain interval. Okay. So that's why we can use histograms. So what I like about this software is it shows how dot plots and histograms can kind of morph between each other. So I'm going to go ahead and drag a dot over and see already it's making groups for me. Okay, so values that are close to one another are kind of bin together in the same group. Right? So I have 64 to 71.9, 72 to 79.9, and so on. Okay. I'm not a big fan of those intervals. I want maybe multiples of 10. Okay, so let's start at 60 and use a bin width of 10. Okay. So anybody whose abdominal girth is from 60 to 69.9, right, just below 70, is in the first bin, and then 70 to 79.9 in the next bin, and so on. Okay. So now that the dots are bin together like this, and you can see that they're almost forming bars, we can figure out how many people have abdominal girths above 100. Okay, so it's still going to be hard to count, right? So let's go ahead and do this. I can click on this, and it gives me the number. Okay, so that's 33 plus 5 plus 1. So that'd be 39 people in this data set whose abdominal girth is above 100. Okay, so by binning the data in this way, right, it makes it easier to answer questions of how many or what percent. Right, had I clicked on the percentage sign, right, now I can see what percentage of individuals in this data set have abdominal girths above 100. 7 plus 1 plus 0, it's about 8%, right? These are rounded numbers, by the way. Okay, but this graph that we're looking at is technically not a histogram yet. It's kind of halfway between a dot plot and a histogram. So we've binned together values in kind of groups or bins of 10. And so next we need to make them look more rectangular shaped. Okay, so let's try the fuse rectangle. Okay, so now instead of individual dots, there's little slices. And each slice represents a person that fell within that bin. And when all those slices stack up together, we get a bar. So now we have something that's a bit more like a histogram. So yeah, that's pretty much it, how you go from a dot plot to a histogram. And again, the advantage of a histogram is it's easier to answer questions of how many or what percentage.